Hi, this is Fred. Today we're going to use the same network that we've been using. We're starting out with our NAT box here, and this is going to be an area designated for OSPF. Open shortest path first. Let's take a look at it here. So there's only a couple of different ones. We're going to use a show IP OSPF interface, and that's a little bit different than the EIGRP commands we used. This one we used, that one we used, and that one we used before. Alright, OSPF is a little bit more complicated, and one of the things that it does is advertises link states. So if you lose a line like we're going to do later on, it's instant, man. It sends out the advertisements right away that this path is no longer available, and everybody has to calculate new paths. So it's better than RIP, and there are some better things about it when you compare it to EIGRP. You need to investigate these protocols a little bit more than what we're doing in the lab, right? All we're going to do is implement them. If you want to understand them, you're going to have to read about them a little bit. Now, we have a process ID also, same as the GRP. We'll use 100 for this process. It doesn't really matter too much what you use for a process ID, but this number is really significant, the area ID. This is going to be somewhat similar to the process ID in EIGRP. Whereas the process ID for OSPF, they don't have to be the same for a group to exchange information, but the area ID has to be the same. You can exchange information between other areas, but you have to use some special commands that we're not going to go over. Now, you'll find some places where you have to use, it says you have to use the rather than a subnet mask, a wildcard mask. In some cases it says that some routers will let you use the subnet mask, and it will change it to the wildcard mask. So I'm just simply going to use the wildcard mask. I'm going to go with what the first thing I read was, that you have to use them. So I'll switch everything to a wildcard mask. Just like before, we only need one default route, and we're going to have to redistribute it. And OSPF, again, is like EIGRP, is a classless routing protocol, and that's why we're using the subnet masks, so that we can identify, you know, like our smaller networks, our /30s, right? Let's see, we need a passive interface again, so that we're not sending OSPF updates out of our NAT box. We don't want anyone on the internet to be able to capture those and identify our internal routers and their configurations, right? Okay, and we already talked about that. So here's the group that we had. I'm going to change this to OSPF ops OSPF, and oops, we'll leave that as 100. Actually, I like 1. I'm going to use a process ID of 1, and so I'm going to change these to wildcard 0.0.0.255, and I'll just change all these others here with a copy and paste. There we go. And these were already done. Note, so with EIGRP, we did them both ways and it worked. Probably should try it both. Nah, I'm just going to leave it. So we're going to, on the first First one, we're going to need a passive interface, so I'm going to copy that also. Copy. Router is the command again that turns on routing protocol configurations in config T. So there's our access list, turning on NAT, access again, list again, use a wildcard mask just like we're doing in OSPF. And there's the command that turns on NAT. Here's our only default route that we're going to use. And paste that in. There it is. And it looks good. Now we're not going to, whoops, no, you know what I forgot? I forgot my area IDs. These are all going to be area 0. So, area 0. Whoops. After all that talk up there, I forgot it. So I'm just going to copy these in here. Or paste them in. There we go. I should be able to just copy this right directly into all these other ones. Let me move up here and keep my notes correct. There we go. So we go down to router B, and I should be able to change these commands quite easily with a copy and paste. There it is. Not going to change any of the other configurations. And we're hoping that this will work. If it doesn't, you won't know because I'll probably delete this video and redo it. Just changing each script for each router. Down to the last one. And there we go. Let's see what we got going here now. I should be able to, oh, I'm going to bring up my task manager. I guess you don't have to do this every time, but I'm so used to doing it every time that it makes me feel good. Boot this one up. Looking good. Boot this one up. And this one. You can start them all at the same time, but it takes a little bit longer when they all jam up the processor. There we go. Now I've turned on VMware. Every once in a while I forget to do that. We have to remember that VMware, VMnet 8 is the default VMnet attached to the NAT, little NAT router in VMware. So I'm hooking my NAT box externally into that internal VMnet. There we go. Let's go over here and copy this for router A. Oops. There it is. Always hangs up just a minute there on that DHCP for the IPNet outside. It's acquiring an address. DORA, remember? And there we go. So, and again, I should be able to ping 8.8.8.8. There, whoops, 80%. Good. So let's go over to another router here, B. Console in. There we go. So these are changing state. And remember, this is a link state protocol we're using now. When they change state, OSPF goes into action. Copy, Alt-Tab, and paste. Cannot pick a router ID. Now this is a process that it's a complicated process. I'm not going to go into it in this course. We can look at it in IT 160 if you take it. There are elections, there are processes that happen when these routers communicate with each other, and we're just going to let it go. Okay, but I do want to do my show IP route and see if I got, I didn't get my redistribute static. So let's look back at, and I may have used the wrong command. Let's see. ENAT, OSPF, passive interface. I don't think I redistributed the static route. Okay. Let's look back up here and see if I... Yep, I forgot to put that in here. I have it up in my notes, so let's copy that. Take it down here and put it in this one. I'll just grab the whole script again. Copy. And that, and only classful will be distributed. I think that was a classful address that I put in my static route. Yeah. Well, it's the Cisco default route. I'm sure it'll pick it up. Okay, let's go back over here now and see if we picked it up. Not yet. We'll come back to this. So, console into G. There we go. Show IP route. Whoops, rut. Oh, okay. Now we've got an O in here. We had a D last time, right? And that was from, we didn't get our default route yet. I may have the wrong command in there. I'll go back over here and see if it came into B yet. Nope. I'm going to have to pause this and see if I got the right command. Okay, I forgot to use, I haven't used OSPF in a long time, I forgot to use this default information originate command. And I don't remember if I've always had to do that or not, but I've only ever done a few OSPF exercises. So I put this in router A, and you can see it here in router A. Passive, redistribute. There we go. So I put that default information originate command in here, and what that's doing is saying where the default route is going to come from. So any static routes that are in there need to be passed out. So let's look and see. Router B, I just pinged 8.8.8.8. Let's look at our show IP route again. There we go. And so we see that, and it tells us where it came from. Fast Ethernet 00, and it's good. I'm happy with that. So let's look at these other commands that I had. So I'm going to do a show OS IP. So show IP OSPF protocols. Nope, show. I don't need the OSPF in there. Protocols. I popped that up so I could look at it and make sure I did it right. Protocols. And there we go. Shows our areas, our wildcards, and shows what area we're in. No stubs. And it's basically getting information from the other routers and putting it in this table. So as we go along, we should get a bigger table for each one, right? What else do we have here? We got router G up, so we can do show IP OSPF interfaces. Should only be one on here, right? Yep, there it is. Fast Ethernet 00. So show IP OSPF. LSA link state advertisement. There's a lot of jargon that goes along with every one of these protocols, and that's what you're going to be doing in your reading if you choose to. Let's see. We get down here to the same information we had there before. Area number 1, stub, no stubs, and good. So what do we have now? Show IP route, and there's our default gateway again. Okay. Ping 8.8.8.8, and that's pinging right past everything else. Good. There we go. So we solved that problem, and it was because I didn't have that default originate in there. Redistribute static and default originate. Let me put that up in my notes in case I use these again. There we go. So where are we at? Router B, router G we did, and router C we're up to now. Copy. Let's see, router C. It's already booted up. We're going to console in, paste. Let's see, show IP route. And it hasn't gotten them all yet. We'll see what happens over time. They're coming. So it's got them all now. I should be able to ping out, and I should be able to ping that dog leg, right? So I'm pinging Google, and I'm going to ping 192.168. What's that up there? 130.10. Yep. Let's boot up another one. Or already booted up. Let's get the configuration in there. Router F. Copy. Alt Tab. And paste. Alright. Show IP route. This gives us an indication of how fast they're converging as we build them. Oh, there it is. So it's converged. Let's ping 192.168.130.10. Yep, and 8.8.8.8, right? So the only real difference between this and EIGRP so far has been I had to put that default originate command in there. So what's next? FD, router D. Copy this. Okay, and bring up a console for router D and paste it in. Paste in its configuration. So show IP route. It already got it in there. Too quick for me. So ping 192.168.140.10 and ping 8.8.8.8. Sure enough, 100%. Let's see, one more router and then we'll break a line, see what happens. Console in. And router E. Copy. Now you can combine these. We would have to design a bit of a different network for it to have any value. We could have OSPF on the ends oh, look, it didn't. We caught it that time. So we got one connected route. There they are. So all those routes are showing up. We should be able to ping out to everything. And ping that other dog leg. So what do we ping? 140. So I'm going to ping 192.168.130.10. And it worked. And we should be able to ping this one from one of these others. Have a high probability of it working, right? So we go over here and ping 192.168.150.10. There we go. So we pinged everything. Now what we want to do is I'm going to go back over here to E. And actually, let me go over to for this one here. I don't think it really matters, E or F. Either one will work for this. So last time I did it with E though and broke that wire. This time I'm going to do it with F and break this wire, right? So let's bring up our command line. I'm going to bring it over to the side here and bring this over. So this is the wire I'm going to break right there. What was our command? So I'm going to ping 8.8.8.8, and there were some other commands I can put out here, right? Repeat, I love Cisco. You don't have to know what you're doing. All you have to do is put the numbers in, or question mark, right? So count, I'm going to do 100. I just did 100 last time, right? There we go. And I'm going to come over here and delete this. Uh-oh. It's broken. And it shouldn't take very long. Let's see if it's as fast as EIGRP. I think it's taken just a little bit longer than EIGRP. We'll see. Well, of course it has. We'll wait. There it is. Yep, I think it took just a little bit longer than EIGRP. It's kind of neat to set up a bunch of. I probably should have timed it. You want to see what the impact of these different things are. You only have 2 paths out of here though, so we can't do a whole lot, but we can test the comparison. All right, so let me hook that back up while I'm at it. Bingo, and then do this again. We can use the trace route command to figure out where the what direction they're taking, and we should be able to see that change, right, over time. Okay, so we've done 3 routing protocols, and again, you can combine these routing protocols with different commands, but basically it's up to you to do a lot of reading, figure out all the different configurations you can use with these protocols, and but know that you can do a simple configuration with just what we did, and we transitioned from the vector protocol to the one that uses bandwidth and availability, and to the one that uses link states. All right, thanks for coming.